In this video we will be talking about the Owasp Top 10 Web Application Security Risks. But before we dive into the top 10, let's talk about the Owasp first. Open Web Application Security Project is a non-profit foundation that aims to improve the security of software through community-led projects such as the Top 10, which the organization is most known for, and some other tools and resources that are absolutely free to use. The organization has chapters spread throughout the globe to multiply its reach into the community and spreading the awareness of application security. Moving on to the top 10. The Owasp Top 10 Web Application Security Risks is a standard awareness document adopted by many companies and organizations to minimize risks in their applications. The top 10 is from a broad consensus that has been deliberated to come up with the most current and critical web application risks. Developers use this document as a guide towards secure coding as it provides awareness and mitigations on the application risks. But for us penetration testers, it serves as a testing guide on what are the common vulnerabilities in a web application, and it also contains basic principles on how to test for the vulnerabilities. The risks in the top 10 has been rated according to its exploitability, prevalence, detectability, and impact. Starting off with the number 1 in the list is injection. Injection vulnerabilities exists in an application when user-supplied data are left unchecked and processed into commands, queries, or the web page itself. Imagine the human body as the vulnerable application. The body takes food as an input, but it has no idea if the food is edible or not. This is the same concept with the injection vulnerability. The application lacks the ability to determine which input are hostile or not. There are different types of injection attacks. There's SQL, Operating System Command, LDAP, HTML, and more. For SQL injection, these occur when applications use raw queries to manipulate data in the database. The user input is directly passed into SQL commands without proper sanitation. For example, a login form would require a username and password for authentication. These parameters will then be submitted to the back-end server to be queried to the database server to look for a match to authenticate the user. The query for that would normally look like this. The data from the input form will be inserted into the SQL statements as search parameters, which would return a record if there are matching records and authenticate the user. For an injection attack to occur, we will submit data that would alter this statement to contain our own query. If you look at the syntax of SQL statements, it requires a delimiter to isolate the data from the command to be executed. To exploit this, we will submit a data that would close the delimiter, which is a single quote or double quote depending on the query. And then, after our closing quote will be our own set of commands to alter the output of the original query. If we put in, or 1 equals 1, the SQL statement would return to be true since 1 is always equal to 1, and this would authenticate the user in some cases. If you have identified username, you can also insert that to log it in like this without requiring a password. That's authentication by pass using SQL injection. Now how about dumping the databases? It is the same concept, but it would require a feedback from the server to be visible. The attack surface should be a part of the website that would query data from the database and display it in a page or a visible reaction. This could be an article page that is dynamically generated where the content is stored in the database, a search function, or even an image, as long as there is a query to the database. This brings us to the types of SQL injections. In-band SQL injection, wherein the exploitation and feedback or result will use the same channel, just like the example we had. In-band SQL injection can either be a union-based or error-based. Union-based, as the term itself, uses the union SQL command to alter the vulnerable query to display other data in the database. For example, a normal query to extract the title and genre from the movies table would look like this. And, login and password from the user's table. Using the union command, it will combine the two tables into one where the result is the unique records from each table. To test for this vulnerability, we'll try to inject a simple order by to check how many columns are queried on the current statement. This is a trial and error test, and since the page displays 5 columns, we'll start with 6. We'll do this until it returns an error. Eight causes an error, so there are 7 columns. Let's inject the union command and select 1 to 7 to identify which columns are displayed. The table can be any table in the database because if it does not exist, it will cause an error. We'll use information_schema, tables which always exist in MySQL databases. We have the columns 2, 3, 5 and 4 displayed. We just have to replace that with the column names or data that we want to display. Like current user and database. We have the current user here as root at localhost and bwapp as the database. Identify tables in the database by displaying the table_name column. Now we have the table names displayed here. Let's try extracting data from the user's table. Just change the table name and columns to display. Now we have the data here. Moving to the error-based injection. Error-based injection relies on error messages thrown by the server. These errors are deliberately triggered to extract data from the server. Consider this query. The count asterisk would always have the same value. The concat select user in hex floor random 0 times 2 would have 2 results. Now aggregating these results and grouping it by column X will result to 3 records. 2 of which will be duplicates and would cause an error since the group by function requires unique values. Injecting this into the vulnerable application will result to an error that would display the information we are extracting in the error message. If you noticed on the payload, we are using nested select statements. This is just to make sure that the whole SQL statement, including the application's SQL statement that we injecting into is still valid and would be interpreted by MySQL. Now you see here that the error message contained the information of the current user. Inferential is the tricky type of SQL injection. Sometimes called as blind SQL injection because the results will be less obvious as the in-band. The results would depend on how the server would react to the given payload and would take time to gather information. Under this category are two types. The Boolean-based, which is where the payload would contain a statement that is either true or false and the changes in the HTTP response would indicate if it were true or false. To test this, we could send mathematical equations like 1 equals 1 which would return true and 1 equals 2 for false. This web page is vulnerable to SQL injection, but as you can see the methods for the union-based injection is not working. We'll inject Boolean-based payloads such as and1 is equal to 1. The page displayed the contents as usual. But if we put 1 is equal to 2, which is false, the page displayed an error because the SQL statement returned false. The next step for this attack is to enumerate the contents using a dictionary, which would take time. An example payload is something like this. The page displayed the content, which means the database name is bwap. Next type of blind SQL injection is the time-based. This is similar to the Boolean-based wherein it also depends on true or false statements. The only difference is the results are not visible through the HTTP response and it will solely depend on the time delay we inject into the statement if it's true or false. For example, if the statement is true, sleep for 5 seconds before the server responds. If it's false, then do nothing and the server will respond immediately. Let's inject the Boolean statement. Since we already know the database name, We'll put it in the comparison to get true as a result. And let SQL sleep for 1 second before responding. Now, operating system command, XPath, and other types of injections use the same concept. Hostile code is injected to be processed and carry out the objectives. In this example, the DNS lookup function of this page is exploited by concatenating another operating system command into the function where the results are echoed back into the page. This is possible because the supposed to be target domain for the DNS lookup is not sanitized and directly used in the PHP shell exec function. And the semicolon in bash indicates the end of a command line and would allow a next command to be ran after the first command. We have injected the uname and ls command into this DNS lookup page. And results were echoed back to the web page. The most important thing about exploiting injection vulnerabilities is that you are aware of what the programming language or operating system or whatever interpreter is used in the application that will run the payload that you will be injecting.